For video 4 of quadratic functions and their graphs, we're going to be doing much of the same that we had done in video 3. We will be graphing these functions by hand. So before we begin, we should call out the different transformations that we are seeing in this function g of x. Before I do that, I just want us to note that I do have a table of values from the parent function f of x is equal to x squared provided for me. I'm going to use this in order to kind of keep track of all those transformations, and this way I'm not going to lose the vertex of my parabola once I've transformed it. So let's start going and identifying these different transformations. The first one that I'm noting here, I'm going to start with the plus 4. First off, note that the plus 4 is happening outside of the function. It's happening away from the square, or in other words, it's not inside those parentheses. If this operation is outside of the function, 1, I can take it literally, so I know I'm going to add 4 to something, and 2, if it's outside of the function, it's going to impact my y values. Note here, I'm actually going to go up 4 units. So I'm going to come to my y values, and I will add 4 to each one of them. So don't actually take care of the addition yet, you just want to note it. So the next thing that we're going to note is we have an x minus 2 inside the function. So again, note, if it is inside the function, it is impacting the x values. If it is inside the function, we want to think of the house of lies. So in this case, if I see an x minus 2, I should think positive 2. And this is going to tell me to move to the right 2 units. So I'm going to come to my x values, and I will add 2 to each of my x values. Lastly, we have a negative 1/2 being multiplied. It is outside of the function. It is not within the parentheses. It is happening away from that squaring. So there are two things that are happening here. One, the negative tells us that we are going to flip across the x-axis. And the 1/2, so we're working with a fraction that is between 0 and 1, is going to cause the parabola to compress by a factor, so factor referring to multiplication, of 1/2. So again, it is outside, it is outside the function or the squaring, so it is impacting the y value. So I'm going to multiply my y value by negative 1/2. And this is why I didn't want you to take care of any sort of evaluation or calculation yet. Because what we want to note is our order of operations tells us that we need to do the multiplication first, followed by the addition. So now we're going to go ahead and update our coordinate points. So negative 2 plus 2 will give me 0. Negative 1/2 times 4 will give me a negative 2. And then negative 2 plus 4 will give me positive 2. Go ahead and adjust all of your coordinate points. And when you're ready, press play. We'll review them and then graph. So now that you've completed your calculations, you should have 0.02, 0.17 halves, or instead of 7 halves, you could have written 3.5 or 3.5, 0.24, 0.37 halves, and then 0.42. So notice that our vertex, again, calls out those vertical and horizontal shifts. Remember, we said we were going to go up 4 units, so that's why our y value for our vertex is going to be situated at positive 4. And we had also said that we are moving the entire parabola to the right 2 units, so that's why the x value in your vertex is going to be a positive 2 now. So now we can go ahead and graph this, and we'll note that we have 0.02, 0.13.5, 0.24. It's kind of a coincidence that they actually land on one of the parent function points. Then we have 0.3 and 7 halves, or 3 and 3.5, and then 0.42. So we'll go ahead and we'll sketch that in. And as before, the parabola that you see in green is just the parent function. You do not need to include that in your work. I just included it for the video so that you had kind of a point of reference or something to compare it to. But now, kind of note here, we can see all these transformations happening. We can see the horizontal and vertical shifts, so in other words, moving up 4 and to the right 2, is denoted by your vertex. In this case, since we've flipped it, because of that negative, we now have a local maximum point, so this is the highest point that this particular parabola in blue is going to get. And then we're also noting here that the parabola itself is wider in comparison to the one that we have in green, and that's because we're working with a leading coefficient of 1/2, in other words, a value between 0 and 1. This causes it to open wider, or in other words, compress. Let's go ahead and take a look at another one. Again, I have my table referencing the points from my parent function. So let's go ahead and start outlining what each of these transformations means. So a -1 or a -1 on the outside means that we are going to go down 1 unit. So I'm going to come through here, and because it's on the outside, I know that it's going to impact my y values, so I'm going to subtract 1 from all of those y values. The next thing I'm going to note is that I have an x plus 5. Remember, think of House of Lies. So this is going to go to the left 5 units. And again, anything inside of the function, so inside of those parentheses or inside where that squaring is happening, is going to impact your x values. So I'm going to subtract 5 from all of my x values. Lastly, we have a multiplication of 3. And the 3 is on the outside of the function. So this is going to impact all of my y values, and this is going to cause it to stretch by a factor of 3. So that means that I'm going to multiply all of my y values by 3. So feel free to go ahead and pause the video really quick and take care of these calculations. When you press play, we'll review what those will look like. So again, we should get points of -7, 11, -6, 2, -5, -1, -4, 2, and -3, 11. Again, calling out that vertex, we can see that it is clearly indicating that we're going to go down 1 on the y values, and we're going to go to the left 5 on the x values. So again, what we had already kind of seen revealed to us in the function to begin with. So when we actually graph this, again, these last 2 points over here, I'd either have to get creative and go off screen, or I could just leave them off. I probably would be able to graph this parabola with the 3 central points on my list. So -6, +2, -5, -1, and then -4, +2. So going ahead and graphing this and kind of just doing a quick sketch. So again, we can see our parabola, our vertex of our parabola has moved down 1 and to the left 5 units. I'm also seeing that it did not flip because there is no negative out in front, so it should be opening upward as we see it. And since I'm multiplying by a value greater than 1, it should look skinnier, it should look stretched, which it does in comparison to the graph of the parent function that you see here. So now I want you to go ahead and try a couple on your own. So go ahead and copy these down and give these a try. I would go ahead and label everything, so note, is it going up or down, left or right? Is it going to be stretched or compressed? Is it going to be flipped? The other thing that I would encourage you to do is work with the same table of values that we have been working with from the parent function, and go ahead and start to include those transformations in the way that we've been doing in the previous 2 examples. When you're ready, press play, and we will review these 2 together. So for our first function, f of x is equal to -3/2 times the quantity of x plus 2 squared minus 1. So the -1, I'm noting I'm going to move down 1 unit. X plus 2, so again, think opposite. So instead of +2, think -2. So I'm going to move to the left 2 units. And then a -3/2, so that's telling me I'm going to flip across the x-axis, and 3/2 is bigger than 1, so I'm actually going to see a stretch here. So again, I've included all of my values here, so -2 on my x values, because that's happening inside of my function, and then I'm multiplying a negative 3/2 by my y values and then subtracting a 1 from that result, because those two items or those two operations are happening outside of the function, so they are impacting your y values. So then we get the coordinate points that you see outlined here in the center. And when I graph it, again, I can kind of see and take notes and make sure that everything looks good. So my vertex, it did go to the left 2 units, and it did go down 1 unit. And it might be a little bit hard to see just with the naked eye, but I do see that my parabola looks a little bit thinner or a little bit more stretched than the parent function that we see in green. Also, it's flipped because, again, my lead coefficient was negative. For our other function, g of x is equal to 3 times the quantity of x plus 4 squared minus 6. Again, we want to go through and identify all of those transformations. Remember, anything that's happening outside of the function, so any sort of operation that is not happening inside of those parentheses, is impacting our y values. So a minus 6 on the outside is telling us that we're going to move all of our y values down 6 units. Likewise, if we see a multiplication that's happening outside of the parentheses, this is going to be kind of a growth factor. So since I'm multiplying everything by 3, this is going to tell me that my parabola is going to grow at 3 times the rate that it usually would. So I'm going to, again, multiply my y values by that factor of 3. Moving to the inside, we have a plus 4. Remember that when we move inside the function, we want to think house of lies or opposites. So instead of plus 4, I should think of minus 4. So this is why we are going to subtract 4 from all of my x values, effectively moving those x values to the left 4 units. Taking care of that work, this is how we create our new set of points. And when we graph this, we can kind of see, again, here's my vertex. My vertex is negative 4, negative 6. So we can really see that the vertex has moved to the left 4 units, and it has moved down 6 units. Also, take a look at the shape that I have in blue compared to what I have in green. Notice that it is slightly narrower because it is growing at a faster rate, and that is coming from that multiplication of 3 in the function. So this concludes the explanation for this problem. If you do have any questions, please feel free to reach out.